All right, so this is the beginning of a new trimester. And if you guys haven't got it, where are the copies? You didn't get a copy of the assignment from yesterday?
Me?
Yeah,
I did, but I can't.
they're here. I got extras.
Can I get a new one?
All right, so I want to start off this trimester going over diagrams. I got like 10 videos on this diagram already, but I want you guys to start thinking of troubleshooting and how to fix equipment. And troubleshooting is not always putting a meter on something. Sometimes you can tell what's wrong just by seeing what's working and what's not working, and reduce it to like one or two parts of the problem. So I gave you 4 problems on a Whirlpool dryer, and I gave you 3 problems on a Frigidaire dryer. So this is the Whirlpool dryer, and what you were supposed to do is you were supposed to tell me if the dryer was running and not heating, for example, what parts would you test to troubleshoot it, okay? So all we're doing now is just identifying what we would test. We're not going to go in full detail of why this part failed and what was wrong. We're going to build on that, because when you guys come back after Labor Day, you're going to have some more diagrams on refrigerators, on stoves, and other appliances. And I want at least 2 or 3 times a week to give you these, because I want you to continue just to constantly look at diagrams. A lot of people have a hard time reading and understanding diagrams, and the problem is they look at it, they don't know what to do with it, and then they walk away. The next time they look at it, they're in the same place. It's the repetition of you looking at it and understanding what each part is. Little by little, you look at the whole diagram and you understand how it works. It doesn't happen overnight. All I need you to do is understand, okay, this is a thermostat heater. I know where it is. I know what it does. I know how to test it. Okay, I got one piece down. And break it down piece by piece by piece. And then we can build the whole diagram together. So all we're doing now, and you guys already did some of this in your basic electricity practice diagrams, and we have them on the member side of the website. We're saying that the dryer runs, but it does not heat. Okay? So really what we need to do is we need to identify the heating circuit. Okay, so that's the first thing I'm going to do, is it runs and it don't heat. And I'm going to say, well, the heater, when do you want to come up here and do the heating circuit for me on the board? Just like how current flows through this diagram just for the heating element? Nobody? Nobody? Okay, I see you all are really excited to be here. You're all looking at each other. Who's going to go? So this is the path. How much voltage goes to the heating element?
240.
240, 220, 218, 208. It depends on the voltage, but it's in the 200.
Yeah.
Okay? Because like in this room, they built this room as an addition onto the main room, our shop. And when they built it, the current electrical panel in the other room didn't have enough space for this room. And when I mean space, it's not just a place to put a circuit breaker, because a panel in your home can only handle so many amps coming in. 100 panel amp, 150 panel amp, 200 panel. So even if there was space to put more breakers, you still can't use more amperage than the panel's designed to handle. So when they built this addition in my office, you guys see this big transformer looking thing on a pedestal, and they added that to provide power here. But what it does is it connects to the existing power of the room, and when you have a transformer that works off of existing power, it can never give you the same exact power. So in this case, we got 240 coming in, we got 208 on the other side. So in this room, when you check, you might get 208, but out there you might get 220, 240, because they're on different power supplies. Okay? But going to this, it tells you right here, these arrows are not wires. They're just saying from these two, we have 240, and then these two, we have 120 volts. Okay? So let's start going, what would we test? Well, always, when something does not work in an appliance, the very first test we need to make, and you guys don't say because we said it yesterday, what is the power supply? Very good. Dry runs and don't heat. They say, well, why would I check power?
Make sure
Make the right voltage going to it.
Well, if it runs, what am I talking about running?
The motor?
The motor.
the motor.
Because the heater won't work unless the motor works, because there's a switch here in the motor. The motor has to run for the heater to work.
Yeah.
And that's all dryers. And that's as a safety to keep it from turning the heater on without the drum turning and the fan moving air. So we want to make sure we got 220. The motor's off 120, and that tells me that that is good. Just by knowing the motor's running, I know here and here, I have 120. So the point of this exercise is what is not working, but you have to say, well, if the motor's running, I have 120 coming in. I don't need to check line 1 to neutral. You know, I've talked to some of my guys, and they'll tell me, oh, the dryer's not working, or the dryer's working and not heating. And I check power, line 1 to neutral, I got 120, line 2 to neutral, I got 120, and line 1 to line 2, I got 240. And I'm like, why did you check line 1 to neutral? The motor's running.
Yeah, that's one.
You know, you open up the door and the light comes on. I have 120 volts. So before you even start throwing your meter on there, you have to look and see what's working, what's not working, and we can eliminate things that we don't have to test. Because troubleshooting, going through a whole machine every time you want to check for a problem is time consuming. As technicians, we have 8, 10, 12 calls a day. We don't have time to spend an hour on every job. So we got to get in there, test as minimal things as we need to test, and get out. So power is the first one. So number 1 would be power. And now once we check power, and let's just say power's okay, we got 240. What do we test? Dryer runs, no heat.
The
You go to heating first.
thermostat.
What runs the,
You're all talking at the same time. Raise your hand. Raise your hand.
Go ahead, Paul.
Go ahead. What do you
Go
guys
ahead,
think?
Paul.
Fuse.
Okay, thermal fuse could be one thing. Vinny, you had something?
that's what I was going to do
Okay.
first.
Termostato.
The thermostat? You have something?
The heating element, the resistance.
The heating element?
Thermostat, yeah.
¿Qué más?
Thermo límite.
Esto?
Es un termostato.
It's both
Son
thermostats.
dos.
Yes.
Uno es el límite.
As
el otro no.
operating high
Yeah,
limit.
limit.
Yes.
Taking both.
What?
Says you was talking both, checking both.
Yes. But he was saying operating and high limit. Is that it? Is that all the things we would check? So the
Yeah,
idea
all the
is,
timers and everything else is going through.
okay, well what about this centrifugal switch?
Yeah, because it's not.
That would stop the motor, right? I mean, stop the heater, but it's in the motor, right? Okay. What about these switches?
The switches.
So they close.
It's a part
They're
of
open,
the,
they're
it's a
open.
part of the
They're
circuit.
happy.
Okay, wait.
It's a part of
Raise
the
your hand,
circuit.
you're all yelling. Huh?
Eso tape.
No, but tell me exactly which one you would test. Like, this one is C to H, this one is C to B, this one's B to A.
All three, no?
Well, we're not even going through here for the heater, so why would you check C to H?
B to A.
Alright, the line show me how power goes through this diagram to that heating element. Am I going through that switch to get there? So no, we don't check
So
that.
you go C to B.
You say C to B, huh?
Yeah.
Is that
It
it?
has to close down. You gotta go to
They're all,
then B to
they're all
A.
open.
B to A.
B to A.
Okay, you're half right. Because this goes back to what I said at the beginning. What is working?
The
The,
motor,
the system is working.
What is working?
The dryer's working.
the
No,
motor.
but dry runs the motor.
runs.
Yeah.
Okay, now watch this. And this is why I did this exercise. You're not gonna come down to one thing. Sometimes you can narrow it down to just only one thing would cause this problem. Okay? But what we're doing is we're narrowing it down as what would I test if I had this machine doing this? This is the problem. Here is the circuit. If you couldn't eliminate things, then you would check every single thing in the circuit. But if you wanted to save yourself time, we'd start eliminating what we know is working. And if I told you the motor was working, well then let's take a look at the circuit for the motor. Do I come here for the motor?
Yes,
Yeah, we start here too, don't we?
yes.
I'll use a lighter color here. I'll come down here And that don't go to the motor, right? So how do I get to the motor?
To B.
C to B, right?
Yeah.
So if I go through here to the motor, and then the motor's running, this is how it goes out. See, you said check C to B because it's running and not heating, but C to B has to be good because the motor's running. I don't have to test that.
Okay.
So you understand what I'm trying to get you guys to see
Yeah.
is
Yes, time.
you see what circuit's not working, but then see the circuit that is working and rule out that that's what I have to test. So basically I would take an eraser and say, okay, well, if the motor's running, I'm just gonna erase this. Now, my starting point is at B. I don't even have to check that because that's for the motor. So I'm eliminating that as one of the things I need to test. Does that make sense?
Yeah.
Yes.
Okay, so let's try the next one. This one, dryer does not heat and runs forever. And the lady turns it on, goes to sleep at night, she wakes up in the morning, the dryer's still running, clothes are still damp, but it never got hot.
Because the eating.
So what are we looking for?
The eating.
It has to, no, it's a sensor. Something's going on with the sensor.
Something's going on with the sensor.
I'm thinking. Because if it's not picking up, usually on a dryer, they have a sense, it senses moisture and everything. So if it's not working, it just keeps running. Because it happened in my house. So
No,
I'm thinking
actually,
that's what happened.
actually, like, that is your sensor, your thermostat.
Okay. But
And
that's bottom.
in auto dry, like when the timer's here or when the timer goes down here in auto dry, like this way,
Uh-huh.
it goes to the heater, but when this thermostat's closed, this doesn't run. When it opens, the timer runs. So if the thermostat was bad, we wouldn't get heat, but the timer would finish the cycle.
So
And if it didn't go here, the timer goes here directly to power also, right? Okay, so this is how we're gonna do this one. I'm gonna do two different colors because we got two parts that are not working, and I'll explain. So let's go ahead and do the circuit for the timer motor. Power comes in here, goes here, and just for the heck of it, I'm gonna go up here and go out, right? That's how the timer is gonna get power in one cycle, or the timer is gonna get power here. But right now, let's just use that path. So I also want to do what part besides the timer motor?
The
The
heating.
eating. The eating.
The heating element. So let's do the heating element in a different color. And that one we did just a minute ago, that goes this way, right?
Mhm.
Okay, again, we have to look for what first?
240.
Power, right? Because both of them run off 240 and the motor can run.
Mhm.
So 240 would be the one thing. But now where do we begin our testing? Because we have two separate circuits here.
Testing the eating switches.
Okay, so first of all, we would only test here if we got proper power in the wall.
Yeah.
Okay, but let me ask you a question. C to B would stop the heating element, but does that have anything to do with the timer motor? No, so you know what? I'm gonna get rid of
Motor's
it.
still running.
Here. Okay, what about B to A? That's only for the heater, right? So basically, I'm going to just erase all of this because none of this up to this point have anything to do with the timer motor circuit. The timer motor circuit's what's in yellow. Now, if I took the individual timer circuit that's different, I'm gonna go here and remove this because this doesn't have anything to do with that heater circuit. It stops there. Where I need to go is where the two overlap.
Which is on the top, B, whatever.
So that's just a piece of wire. That's just a piece of wire. The only part in the machine is a centrifugal switch.
Switch.
That's the only part I have to check. Now, it would be slightly different if the timer went down here. It could change. But what I was trying to show you is that one switch would stop both of them to working, but the motor would still run.
Yeah.
Because if I see that both of them are not working, these parts here have nothing to do with the timer motor. The heater has nothing to do with the timer motor. The timer motor and this timer switch has nothing to do with the heater. So we have to go back to where both lines overlap. That's where we gotta test. Again, narrowing down our test points are going to increase our technical ability and decrease the time we're spending in someone's house checking it out. I get calls from people all the time that simple dryer not working was a timer switch. And you say, that's easy, but sometimes people go up there and they look at it and they just don't know where to begin. This is where we begin. So I'm going to have you guys do more tracing circuits and breaking down what would you test. The only two things I would check is power supply and centrifugal switch. That's it. Yes, sir.
Make sure that you have electricity before you check it.
As I said, power supply. Power supply. That's if we have proper power. Okay. Dryer ones, when the start switch is pressed down. But as soon as the button's released, it stops.
Mechanism.
So let's do the circuit for starting the dryer. We come in, we go here, it goes to the motor here. Centrifugal switch is going this way, and it's wait for us to press. We press the switch down, and we go out. What type of switch is that? Besides the word push to start.
It's open switch.
Normally open.
Momentary contact.
Momentarily.
What that means is that either it is open or closed when you first go to it, and then when you actuate it by pressing it or moving a lever or something, it closes or opens, whatever the opposite is. But when you let go, that switch is supposed to open. So when I press start, what's going on with this dryer as soon as I press start?
Turns on, then it shuts off.
But there's, not the problem, but I mean, when the dryer's working normally, I press start, what's supposed to take over after I let go of the button? Because when I let go of this switch, it's gonna open, I'll lose power to my motor. So how do I keep the motor going? How does the motor continue to run when you press a button? If you go up to my Whirlpool dryer right now and press a button real fast and let go, it'll start and stop right away. You have to press it and hold it for like a second, and then it'll go. So what's keeping the motor running?
The control board.
There's no control board here. It's a mechanical timer. And the timer's here and it's already sending power.
The centrifugal.
Where?
Between 5 and 6 amp. Yeah.
Give me a fist bump, bro. Fist bump. Because what happens when the motor runs, these centrifugal switches are moving. So watch what happens. When the motor is running, power is going this way, and then it goes up and the centrifugal switch goes here and down. Two things happen when that switch moves. It disconnects the start winding and it bypasses the push to start switch to keep it going. So a lot of people get confused because Whirlpool at one point used a push to start relay. I want to bring it up just for a second.
So it's going, isn't it?
Okay, I'm going to show you this other dryer here. This is also a Whirlpool dryer. Let me just go to here. Now, when they first made this dryer, instead of a momentary contact, they made a push to start relay. And a relay is a magnetic coil that when you press start, when you press that with your finger, not only does it complete a circuit for the motor, it completes a circuit through this coil, and that coil is magnetic. So when they press it down, that coil is what keeps it closed. So a lot of people, especially back when they transitioned from a push-to-start relay to a push-to-start switch, would misdiagnose the dryer because they would press start, let go, and it would stop. Now GE did something different where they put a switch on the pulley that keeps the belt tight. And if the belt broke or that switch was bad, the motor would do the same thing. You press start and the motor would stop when you let go. I remember back in the 80s, I went to a lady's house and she had a problem when she pressed start, and when she let go, the dryer would stop running. And she had a cinder block on top of the dryer holding the switch down so she could dry her clothes.
Okay.
But the dryer would never shut off. She'd have to go and stop it on her own. But she put a cement block on the switch to hold it down. Okay? So it could be a relay, it could have a belt switch, or it could be like the momentary contact. Each one of them will be a different problem. But don't get confused and say, oh, well, Z said if this switch don't work on the Whirlpool, it's a bad centrifugal switch. For that model, yes. And we're going by that diagram. Okay? So we'll look at the other Frigidaire and see if it does the same thing or does something different on the starting of the dryer like that. So the answer to this one was the motor.
The motor?
You'd have to change the whole motor. Because we don't change just a centrifugal switch.
Oh, okay.
You know, back in the day we used to change them, but now you go online and you look up the motor and it says, oh, motor's $73. Centrifugal switch is $73. But the centrifugal switch and the motor come together. You wouldn't want to order just a centrifugal switch, because usually if something goes wrong with the switch, it might have burned the windings or damaged the windings. So, but the point is I narrowed the problem down to just the one thing I have to check. That's it. I'm not going to check this button, because if the motor runs at all, this is good. I'm not going to check the thermal fuse. If it ran at all, even when I'm holding the button, that has to be good. What about my door switch? If it ran at all, the door switch has to be good. It didn't stay running. And I have a tech right now that has a dryer. He press start, runs for 3 to 5 minutes and shuts off. Okay, so again, sometimes things are working and stop working, and not things are just not working at all. Like no water coming in, for example. You get parts that are the opposite. Yes, sir.
So the push to start switch with that issue wouldn't have a mechanical issue either with the switch?
Well, the mechanical issue is inside the motor. So,
Not the
so you're gonna replace the whole motor. The push to start, it doesn't keep the switch closed. When you let go, the contacts open back up. The contacts don't stay closed on this model. Now, on a push to start relay, the magnetic coil holds that switch closed.
Yeah.
But I didn't show you in the diagram here. Here, I think it is. That this will hold that switch closed. So how do they stop the dryer then if you got a magnetic coil here holding that switch closed? You could say, well, I turn that switch off. Yes, that'll stop power going to my motor, but my coil's still energized and my start switch is still energized. So that's not good. I want the whole machine to shut down. So I turn off this timer switch. And if I turn off this timer switch, what happens to that coil? We lose power. So now the switch isn't being held closed by the magnetic field, and that switch is going to open. You know, a lot of times I get calls from technicians needing help on troubleshooting stuff. I have never seen this machine before in my life. But what I do tell them is give me the diagram. I could look at this wiring diagram, and by knowing how the parts work and how all those parts are put together, I know how the machine actually physically functions just by looking at that. I know what it does. You know, so I don't need to see the manual that shows me pictures of the machine and to explain to them how to fix it. Only if they're like trying to take parts off and put parts on and they don't know how to get into it. But for troubleshooting, you'll be able to look at this at one point and it'll be so easy to be like, oh, that does this and this does that and this thing's supposed to run here until this comes over and this happens. But this will only happen through repetition, constantly going over diagrams. I've had a lot of students in the past say, oh, I'm going to take these diagrams home and I'm going to study them. I want to study these diagrams. And I know that they mean sincerely that they want to study them. They come back in the next week and they say, yeah, I took it home over the weekend, took everything out, laid everything out. I picked up the diagram, I looked at it, and I said, what do I do with it now? How do I study a diagram? Okay. Let me ask you a question. When you guys went to school, kindergarten, middle school, elementary school, whatever, when you first started learning to read, did a teacher go like this and give you a book and said, here, read this book?
No.
What did they do?
The alphabets first.
You learned A, B, C, D, right? And once you learn A, B, C, D, then what did you learn?
Then I started
Phonics.
Words together.
Phonics.
Phonics and just specific words like the and sheep and cow and you can't read a book until you know what the words are.
Yeah.
So I'm going to harp with you guys. What is this part? How does this part work? What are all the different pieces of this part? If you don't understand that, what is this going to do for you? You're going to look at it and say, I don't see how the two of them are the same. So don't be so energetic that you want to just jump right to a diagram and just start troubleshooting everything. So this is why I have you guys doing 5 different motors. So you learn the different motors, and then when you go on the machines, you'll look at the motor and say, oh, I know what that motor is. I know how to check it. And you're going to look at a diagram and see how it goes in a diagram and then learn how it works with the diagram. That is what you guys need to do when you're here on a daily basis. Every time you work on a machine, you have to have that diagram. Every time you test a part, find it on the diagram. See how it's connected. What other things are connected in series with it? Let's go back to the assignment. Okay, so that was number 3. Any questions on that one, guys? Yes, sir.
Just to get a better understanding of a relay, it's converting low current to high current.
Not necessarily.
Like,
A relay coil could be the same voltage as the switch. But it allows us to mechanically turn that switch on and off, or instead of me having to physically push that switch on and off, for example. Okay, this is a contactor and a fan relay. The coil's here. You give that coil, and inside a piece goes up and down like this contactor, and that's a switch. So this and this are 24 volts. This is an AC contactor. A contactor is just a big relay because it handles more amperage. Same thing as a relay. I put 24 here, pulls it down, allows power to go to my motor or to my fan or whatever I want. The push to start relay, same thing. It's going to have a coil. It's going to have a switch. Okay? In this case, this allows the thermostat on our wall to send power to the here, and then it turns on the parts on the roof. And then when the thermostat says it's done cooling, it takes away the low voltage and does this. So in an AC, yes, we got low voltage controlling a high voltage circuit, but the low voltage and high voltage are separate wires, separate circuits. Okay? Next problem. Number 4. Dryer only is, typo, high heat. I said high head. High heat, 145 degrees in all cycles. Dryer only provides high, I don't know why you keep saying head.
I hate.
It's supposed to be heat. Is the letter T and D right next to each other? No, so don't ask me how I typed that. But anyways, high heat. So this one is not one that you can circumvent in a circuit. I put this diagram only to emphasize that you must understand how the part works. Anybody have the answer?
Well, there's 2 thermostats. One is a certain temperature, and then you got the high limit one.
Okay, no. So this thermostat right here is 145 degrees. Okay? This one is 255.
Okay.
And the idea is this is 196. No, this is 196. This one, I think, is like 300, 325. So what happens is this one controls the heat of the element, but it's where the air goes out of the dryer. This one is right next to it. So if this is 145 and that don't work to 196, it kept going up, we'll shut the whole dryer off. But on the heating element, we have these two. This 250 does not operate to control the temperature. It's if this and this don't work, that one is there. And one way it won't work is if these two are where this one here
145.
and this one are where the air goes out the back of the dryer. These two are on the heater. They're on two different parts of the machine, two different areas. The difference is these two are at the element. The other two require the fan to pull the heat through the machine and blow it out the back of the dryer. And when it goes out the back of the dryer, that's where the other two come in. What if the fan is not working? The fan's broken, or someone didn't clean the filter and it's blocked with lint so that the air can't get down to these two. Then it won't work, okay? But that wasn't what the problem is. What the problem is that it only gives you high heat. Well, that's what this thermostat does. This thermostat will shut off at 145, which is this temperature. So now the question is, how do we get lower heats? If I only got high heat, and the lady says, oh, I use delicate, and it's causing all kinds of problems with my clothes. It's shrinking them, and it's deforming them because it's too hot. Well, how do we get low heat? Because this is the only one that cycles. These are only safeties if that one didn't work. And the problem is I want to lower the temperature than 145. I don't have a thermostat there that's lower than 145. This one I said was 255, and this was 325, and this is 196, so that is the lowest, isn't it?
Yeah,
But there
145.
is a way that this dryer can give you lower heats.
The selector, the temperature selector,
Okay, well, how does the temperature selector work?
it runs.
See this, okay, stop right real quick. I did some of these questions to emphasize. There's some people in here that's been through dryers, and I don't hear them telling me how this works. I've explained it before, which is fine, they just don't remember. The thing is that if you want to fix appliances,
Manually.
you have to know how that works. It's there, and it's this thermostat heater. If I turn on that heater, I can get low heat.
Which one?
This
The
is
one
not
that-
heating the clothes.
Who is this?
This is heating what? And what thermostat is it heating? This one.
The 145.
So this and this are all one part, and I'll show you. Like I said, I've done this before in different videos, but let me find a good image here. Right here. Look at that thermostat on the right hand side.
Yeah.
We got two big terminals. That one says 155. The L is the limit. At 155 is when it opens.
Just
Touched it.
It's at the top. It's on top.
Yeah, but we're
X.
The first runner.
okay. So these two are the heater. These two are the thermostat heater. I'm sorry, these two are the thermostat. Those two are the thermostat heater. The L155 is the temperature. I told you the one on our dryer was 145. This one's 155. The minus 25. So at 155 it opens, and now the heater's off. So the temperature is going to start dropping, and once it drops 25 degrees, which is 130. Switch will close again, the heater will come on, and it'll keep an average in between those two numbers. But what that does is it has a little heater inside the thermostat, and it tricks the actual switch in there. So when the air 130 is flowing outside, the heat that this one is generating is tricking the thermostat, thinking it's 155. and it shuts off at a lower heat. So if we go back to this diagram for a second, if I close C to H, let me just do a different thickness here. If I close C to H here, well, let's go this way. How much power am I putting to that thermostat heater right now?
120.
120. It's coming from line 1. It's coming in neutral. Okay. But what if I don't close this
Stays open.
and I go this way? How much voltage do I have to that heater?
120.
Still bypass.
This switch here is not really much of a switch. A lot of times, if you look at our Whirlpool dryers that we have there, the new ones that are on this back row here, you'll see a little resistor outside of the plug. Like there's a plug that goes on the switch and all the wires go in the back of that plug, and then you'll see a little resistor there. And what happens is the resistor's here, and the resistor drops the voltage here. So we get, instead of 120, we maybe get 60 to 80 volts. So if I lower the voltage, what happens to the heat there? It's less. So I need more heat here. So when I got 120 volts here, I got the lowest heat possible, let's say 130. When I put 60 here, I get in the middle, like 140. If I don't even turn this on at all, I get the high heat of 155, for example, or 145. So the purpose of this is to trick this thermostat and get low heat in the dryer. But again, this goes back to, you need to know how that works. Some of you haven't been to that dryer yet. Now when you get to that dryer, you need to look at this piece here and know what all those terminals do, what they are, how to test them. How else are you going to troubleshoot? Because you're going to look at it and you're like, I've never seen that part before in my life. How do I check it? What do I do with it? What does it do? Why is it there? Trust me, I'm even to this day, I've been in this business now since 1981. Okay? And I still see stuff that are new product, new designs, and I have to go back and research to find out how it works before one of you come up to me and say, hey, I'm working on this machine, how does this work? Because you all expect me to know everything, right? Which I don't know everything, but I know a lot. But the point is that I have to constantly research and learn something.
Keep learning.
If you don't stay on top of your game, it's going to pass you. I mean, if I didn't constantly learn, when I first started, we had no cell phones. That means there was no computerized machines whatsoever. Everything was a mechanical timer. Now everything's computer.
Yeah.
It's changed. If I didn't change with the times, I'd still be working on mechanical timers until they, oh, you got a computer board. I can't touch it. I don't know what to do with it. So when you guys are in here and you're working on a machine, don't just go through the machine, take it apart, and rush to the next one. Because you're only hurting yourselves, okay? I will watch you guys, and I will see what you guys know, and if you're learning, if I see that you need help or correction, I'll help you, okay? But when you're in here, focus on what you're working on. Don't spend one day on a machine. Spend 3 or 4 days on a machine, but don't leave anything unturned that you've never looked at it. Every time you work on it, have a diagram. Make a copy of it. Mark it off that you checked it and put notes how you checked it or how it works. And then create a little notebook of all those things so when you see them again, you know how to check them. Okay? So, on this one here, the problem could be the selector switch, this here, or this here, but it all had to do with that. But there's only those 3 things I would check. I wouldn't have to check nothing else. Could we have mechanical problems or something? Yeah. But the point is you need to know the diagram. Alright? Let's do the Frigidaire. I haven't done the Frigidaire in a long time. Dryer runs no heat. Now, I do want someone to come up here and give me the heating element circuit for me, please. Come on. Come on, someone volunteer. Come on, you're ready to go.
I can try.
Hey, if you're wrong, that's what school's about, right?
Yeah.
Let me try.
So the heating element is right here, and the power comes in here and here. Now, if you don't know how to get from the power to it, go on both sides of the heater and go back to the power.
Yeah, that's what I was just about
That's
to
fine. Go ahead. Whatever way you can see it until it gets easier.
No.
You're doing right. No. You were going right. Keep going. Okay, you did one side. That's it. Very good. That's 2 for 2.
Okay.
2 for 2 today. I gotta stop picking on you and find someone else I can pick on. You know, our rookies are getting a pass for today, but you know, next lecture I'm gonna put them on the spot, right? I want to test their ability. All right, so what dryer runs and don't heat? We've checked power. Power is good. Okay, give me some things we would test.
If it has 240.
No, I said the power's good.
Oh,
Well, okay, really? I just said that. You failed already. I give you props and all this.
yeah.
Okay, so what do we got here? What would stop the dryer from heating?
A broken element.
Your
The element?
Yeah, broken element.
Oh, the element would be one thing. Yes, sir. Anything else?
the fuse.
Thermal fuse.
Yeah, the thermal fuse.
Where's the thermal fuse here?
I can't even see it.
Well, it's here on the board. Come closer where you can see it on the board.
I'm looking at it here.
I don't see no thermal fuse. You're confusing it with a Whirlpool dryer.
The thermostat.
Okay, which one?
The high limit.
Okay, that's one of them, correct?
You just backtrace to L2, no?
Just
Although-
give me parts you would test. Yes, I can do it. You know, but I want you guys to give me the answer. This is what your assignment was.
The control thermostat.
Thermostat, yeah.
Okay, so the control thermostat.
And then switch A.
Switch A. Okay, B to A, and that's B to C. So that switch is a problem.
In
Or
the,
could
in the
be a
timer,
problem.
yeah. And
That's a fabric.
the centrifugal on the motor.
What numbers? Because there's a switch here, 5, 6, 1, and 2,
Is it M1, M2?
Yeah, M1, M2.
M1, M2. There's one more thing.
Is it?
The push to start switch.
To push the start switch,
No, oh, no.
that's up here. That's not in the circuit of the element. It's got to be in that orange circuit there.
Well, if the switch is a part of the motor, then wouldn't the start and run windings of the motor maybe?
No, but I'm not going through those windings right now. Remember, the orange
right.
line, the orange line you drew.
Yeah.
So let's just make this clear so you understand. What you drew is how electricity comes from the plug through the machine to the element and back out. Just how the element gets power. So right now, I didn't draw any orange, or you didn't draw any orange lines to those windings, so they're not part of the fault. I don't have to, if it's not in the orange, I'm not gonna test it.
So then you go from 1 to 2.
It's not the motor. We already got this switch
It's a
in the
wire
motor
now.
here.
It's a
What?
wire. It would be a wire, wouldn't it? On the yellow, on the bottom? Yellow to orange?
I just circled. What did I just circle, guys? Selector switch, terminals 1 to 2. There's a switch there.
Yeah, automatic switch.
You forgot that switch. But just think about it, if you were forgot in someone's house, you'd spend all day checking everything else. I say, oh, I'll just change the heater. Come back, change the heater, still got the same problem. Now you're scratching your head. But you forgot to check that. Okay, like I said, we're gonna do a lot more of these. They're gonna get more complicated because the diagrams are gonna be crazy diagrams. I'm not gonna start off crazy, but I'll go crazy. It's fine. So, any questions on this one?
So does that mean the thermostat heater is a part of that that path too?
Well, it's not path for the current of the element, it's just if I close this, I'm requesting low heat. If I'm requesting here, I'm requesting medium heat because I'm gonna go through this resistor, which is gonna drop power to that. It is gonna go through here, but this is only for low heat, like the Whirlpool one. So that has nothing to do with the actual element running. Okay. Any other questions? No? Dryer does not run when I'm pressing, so I'm pressing
Check
this,
voltage.
I'm pressing this button and dryer don't run, okay?
Yeah, check voltage.
I'll say we check 120, we have 120. So someone wanna do the motor circuit for me? Come on, Paul. Come on. Show me the path for the motor. Motor's right here. We gotta get power here and power here. 4 and 5. Remember, 4 and 5 is when we test a motor, where do we put the power to test it? 4 and 5. All you guys been through motors. We just did that yesterday. 4 and 5.
That's a
So
general
go back
rule
to
of
power
thumb.
and file this one out.
Is that like a general rule of thumb?
Almost all dryers, not every single one, but almost every single dryer, it's terminal 4 and 5 is power in and out. Almost every dryer, it's terminal 1 and 2 on the motor. Now, there are gonna be some differences on some brands and some models, but 99% of them are all that way. So go out 5. And just immediately go down and turn to the right and go back out. Nope, nope, you don't change direction there. Hold on, hold on. Hold on. Get that eraser. And then we'll just remove this line here. You gotta go straight up. Now, change it back to the pen. The pen. No, the pen.
Pen, is pen.
There's a, I can't see it here.
Hold on.
Okay, now follow it up. Straight up. Okay. Not wet. Go down and back up. Go through the door switch and up and out to neutral. Right there, that's it.
Oh, that was neutral, right here.
Yes. This is something you gotta practice. Okay, thank you. All right, guys, let's start from line 1 and follow it in. Let's do them in order of the circuit. Starting from line, well, actually it says line 2 on this side. This happens to be half of a diagram because this is a laundry center with a washer on the bottom and a dryer up top. I only took the dryer part out of that diagram. But starting from here, what's the first thing we would check?
Wow.
Power.
Oh, we got power.
Okay.
Like I said, we already eliminated power. So, what's the first part we will check? Starting here.
The switch
What switch?
is C.
That's
No,
only one terminal. C makes connection to what?
Oh, I'm looking at it wrong.
You can come closer, you don't have to sit that far back.
But there's a switch there.
BC.
I know there's a switch there.
ABC.
Is that B?
BC.
BC. B here, C here. So that's this switch, that's one thing. Keep going, what else?
Thermal.
Thermolimiter?
Yeah.
What else? ¿Qué más? In the order.
Terminal.
What? For the motor, 4 and 5. What else?
I came down.
Now we came down, just a wire, we came back in, went back up.
Door switch? Door
Door
switch?
Start
switch.
switch.
Door
Start
switch?
switch.
And the start
Start
switch.
switch.
That's it.
Yeah.
So, you know, the hardest thing about troubleshooting is people walk up to a machine that's not working and they're like, where do I begin? What do I do first? And this is one of the things we need to do before we start testing. This is like, if you're gonna go on a trip to a place you've never been before, but you have to drive there, what do you do before you go?
Research.
What type of research?
Where to go,
Map
where to
research,
drive, what
directional.
to
You
take.
get a map,
Directional.
and you say, well, how am I gonna get there? This is a map showing you how all the parts are connected together. We just have to find that one road.
That's all we got.
You know, if I told you to get to the airport from here, I think you could probably get there 4 or 5 different ways. We could take the Palmetto, we go down 57 to Okeechobee, we could take the Gratney to 95, you know, or we could take the Gratney and get off on Lejeune Road and go all the way down Lejeune Road, which should take us there. So I got 4 or 5 different ways I can get to the airport. Well, I have 4 or 5 different paths in here. I need to find that one path to that one part that's not working and build my troubleshooting from there. This is the beginning of troubleshooting. We're gonna take it step by step. We're gonna talk about more about what would we test, what would we test, what we test, but by the end of this trimester, I'm gonna be bringing machines in here and we're gonna do live troubleshooting tests together. You're gonna see what's working, what's not working. We're gonna do the same scenario. How are we going to, what are we going to check first? And the order at which we test them and why we would check them. And then we'll also do, how do we shortcut it? How could we eliminate the physical testing to eliminate multiple parts in one test? So I don't have to go down to every part, test each part individually. We'll talk about that as well. But right now, we're just trying to build our mindset is when I walk in someone's house and I press a button and that dryer doesn't run, okay? Now I want to say, well, what do I test? Yeah, I check power every time. But if the power's good, I go to the machine and I'm looking at what do I check on the machine? I don't know what to test. I need a diagram. I need to know how does that power from the wall get to that motor? Well, it's got to go through these parts, and to go out the motor, it's got to go through these parts, and the motor itself could be bad, and that's what I'm going to check. Sometimes I feel like I'm in daycare or something here. Okay. So, just for that, Cecilio. Muchas gracias. El motor tiene pero no prende. So the motor's not running. Okay, when you press start, but it doesn't run.
Yeah.
Okay, so first, show me the circuit. All the way through here?
Yeah.
And up.
Switch it.
Back up. And up. Okay, thank you. Good. So, with this one here, the same circuit we just had, right? But the dryer hums and does not run. What do we test?
The motor.
Well, we check power. If we're low on voltage, let's say we're supposed to have 120 and we have 90 volts, it may not be enough power for motor to run. Now let me explain something here. This wasn't part of the reasons why I did it, but it came to my mind as I'm going over it with you guys now. You could go to a machine, it's not running, and check power, and everything looks good. 120, 120, 240, everything is good. But sometimes when a wire's connected to a screw or something in the wall, if it's loose or the wire got burned, when you press start, the motor's drawing current. And if the wire's burnt or the circuit breaker's burnt and everything, all of a sudden the voltage could drop to 80 or 90 volts
Not enough current.
because there's not enough electrical current. It'd be like you turn on the hose, you had a 50-foot hose, and you take the hose and you walk all the way in the yard to the car. And you go back to the wall and you turn it on, you come back and it goes, as soon as you turn it on, it's got pressure, and then it goes, and it's coming out, but it's just trickling out. And then you walk back halfway and you see like, oh man, someone put the garbage can over the hose and it's crushing the hose. So we had pressure, but as soon as the current flows, the hose being pinched doesn't allow that pressure to stay, so it drops. So we could have something called a voltage drop. So when we do a voltage test for something like this, we must check it when it's off and then do the same test by running the dryer. And you're like, but the dryer don't run. But put my meter and press the start button while I put the meter where the motor's humming and see if the voltage drops.
Then you know the wiring issue.
Then you know, ma'am or sir, you need to get an electrician because it's not your machine. It's the power in the wall. Okay? But let's assume the power is good. If the motor's humming, what is that telling me? What information?
The current isn't there.
There's power going to the motor, right?
Yeah.
So, does that mean this switch is good?
Yeah.
Yeah. How about this one?
Yeah.
How about this one? How about this one? All the switches are good because if any of them bad, the motor wouldn't even hum. I don't need to test anything. Except this problem could be a mechanical problem, which we're really not talking about. But if a lady pulled the filter out and the sock fell down in there and then she put the filter back and that sock is jamming up the fan blade,
Okay.
so the motor's physically stuck, it's going to hum. But we're really not talking about mechanical problems, we're talking about electrical problems. But if that happened to me, all I do is open the door, turn the drum by hand to see if it turns freely and the motor's turning. And then I'd say, sir or ma'am, problem's your motor, it's going to be $275 to fix the dryer. Do you want to get it fixed?
Say that again. If you turn the drum.
If I turn the drum,
Right.
which the belt is turning the motor,
Right.
I just want to see if the motor's locked up. Because
Okay.
if the motor's physically locked up, bad bearings, a cloth or clothing fell down in the vent and is blocking it, then if I try to rotate the drum, it won't rotate either. Or I could feel some heavy resistance against it. But again, what I'm talking about today is not giving you answers to what to test. I'm giving you the instruction of what do I do when I first go to a machine and how do I process it to tell me what to test. Okay? It's just the mindset. So the only thing it could be is if I wanted, I'd go to 4 to 5, press start, and see if I have 120 there. See if it drops here. Because there could be something in the machine, the wire's burnt going to the thermostat, and it's just barely hanging on, but it's 50 strands inside the insulation, but now there's only 2 strands left, the others are gone, and there's just not enough to keep that voltage there. But you would know that if you know where to test and how to begin. Okay, I think this is the last one here, right? Or that was the last one.
Yeah.
So that was the last one. Any questions on this, guys? Yes, sir.
Before you're testing and troubleshooting, is it safe to assume that the first thing you would do is put it in diagnostic mode? Before?
You put it in diagnostic if you're able to put it in diagnostic. Because if you look at these 2 machines, neither one of them have a computer board. So what diagnostics are you going to have? Remember, diagnostics are built into machines with a computer because there's a program in it that allows you to troubleshoot parts. These last 2 machines don't have a computer.
But they don't have like
There's
like
nothing there that has any
no
diagnostics.
checks, nothing.
The only thing close to diagnostics is Whirlpool had a mechanical timer that you couldn't get the machine to agitate on a regular washer like this until it filled up with water. But who wants to wait for a whole tank to fill up? And then what if you're pumping your motors bad and you got a full tank of water, now you're stuck with all this water. So Whirlpool on their timer put a little tiny mark. And if you put that timer right in that one little mark, it'll agitate without water. You guys want to see it? Come on, I'll show it to you real quick. And then we're going to So on this timer here, you see that little tiny notch there?
Mhm.
It's different from all the others. Look at it right there. If you turn the timer and you're, oh, I went too far. I can't watch it in the camera and do it. I gotta look at it and rotate. You put it like right there and pull the timer out, it will agitate without water right there. That one little dot right there all by itself.
See it.
Now Whirlpool